Hey everybody, my name is Bobby Farlice-Rubio and I work at the Fairbanks Museum and Planetarium in St. Johnsbury, Vermont. And I'm going to use this video to introduce you to matter and the elements and the periodic table of the elements where we keep all this information stored. And I'm going to point out some resources that I think you should use. Maybe you can get this book at your library or bookstore by Theodore Gray called The Elements. This book is one of the most fun ways to explore all the types of matter that exist in the universe. And here's the section on iron. I'm going to be talking about iron. In fact, I have a horseshoe too. But in case you don't have this book available, there is also an online available app through the iOS store that Theo Gray also put together. Here it is, The Elements, the periodic table. And if you want to learn about any particular atoms that we talk about, you can find them here because every atom known in the universe is on the periodic table. And so far, we've gotten up to 118 discoveries, but really most of them some of those are not found in nature. Like, the only ones you will find most of the time are number 1s through 92. And anything higher than 92, like plutonium, that was something that was created in a laboratory. It does not exist in nature. But there are 92 natural atoms. And everything that you've smelled, everything you've ever tasted, everything you've ever looked at, everything you've ever tripped on, everything that's ever fallen out of the sky and hit you on the head, everything in this universe is made out of one of the atoms. And that is what we call matter. And when we talk about matter, we can start with something basic, like water. Well, you've probably heard that water can come in different phases, different types of matter. This is liquid water, but if you live in Vermont like I do, then you know that sometimes it gets cold enough for this to turn into a solid, and that's ice. And if I were to get this really hot in a cooking pot on my stove, I could boil this and make the water fly out of the cup and turn into steam or vapor. And then it would be a gas. So we can make water into a gas, we can make water into a liquid like it is now, and we can freeze it and turn it into a solid. Well, guess what? That's the case with all of the elements on the periodic table and the things that we're making out of elements and atoms, because water is not even on the periodic table. Wait a second. This is one of the most important kinds of matter to life on Earth, and the surface of our planet is covered by it, and your body is mostly made out of water. But how is it possible that water isn't an element? Well, that's because water is not made out of just one kind of atom. Water is a molecule. And when you study atoms and molecules, you'll find out that most things are made out of not just one kind of atom, but a mix of different atoms from this periodic table. So many of you have probably heard that some people call water H2O. What does that mean? Well, H on the periodic table is hydrogen, and some of the atoms in this water are the same thing that makes the stars. I just got to say that H, number 1, is the most abundant element in the universe. And if you look here on the app or in the book, you can see that 75% of the whole universe is just made out of H. But water isn't just H. It's not just hydrogen. Hydrogen. If I need water, I should find a hydrant. Maybe if I don't drink enough water, I get dehydrated. So hydrogen is a word that worked its way into a lot of the words that we use to talk about water. But there's more than just hydrogen in water. What about the O? If it's H2O, there's also oxygen. And that's pretty cool. That's pure liquid oxygen. That stuff to make oxygen liquid, pure oxygen, you've got to get it down to 300 below zero, just about, which means the oxygen in this room is much too warm. The oxygen that I'm breathing, I'm glad is not 300 below zero. I'd be frozen. And that oxygen would turn into a liquid, but the oxygen in this room is boiled. It's already a gas. So we'll talk about that too. But water is partly made out of oxygen. So this liquid is H2O, some hydrogen, some oxygen mixed together. And although you know about boiling water, you may have had some spaghetti noodles for supper tonight. So you've probably seen that you can heat up water. When you get it up to 212 degrees Fahrenheit, water boils and turns into a gas. But I'm going to show you a little trick that you kids can try at home without getting any hot water at all. This is not dangerous, but please ask your parents for help with this project, because I'm going to show you how you can separate the two atoms that are hiding in this water, the hydrogen and the oxygen, H2O. If I were to boil this in a pot, it would still be water, steam flying up in the air. But what I'm going to do is going to change this. I'm going to split the molecule into two different things. So this is not pure water. If you want to try this at home, let me show you what you need. A plastic cup is perfect because that allows you to poke two metal tacks into the bottom of the cup. If you can put those tacks in there just the right distance, they'll allow you to attach a 9-volt battery to the bottom of the cup. And what else I've added to this water besides pure water? There's a little bit of salt. Salt helps to conduct electricity. So if you use a battery without the salt in the water, the electricity might not flow through the liquid and you might not get this effect. But this is cold water. I want you to know I got it out of the faucet just a few minutes ago. It is not hot water. But when I put this battery onto the tacks, let's see if you can see it too. The bubbles. I'm making bubbles. I'm making gas. But it's not boiling water. It is not H2O. What you see coming from that tack is H2. I'm breaking the water molecules. I'm turning H2O into H2 and O2. But notice that only one of the tacks is bubbling. Maybe you're expecting that the other tack will be making bubbles too, but something else is happening to that other tack. The one that's making the bubbles is making hydrogen gas. See, if I disconnect the battery for a second, you see the water stops bubbling. And as soon as I touch the tacks onto the battery, you can see the bubbles again. The bubbles, the bubbles. Hydrogen gas, H2, the electricity is separating it from the O. So instead of H2O, I'm generating something different. I'm changing the matter. This is a chemical reaction caused by electricity. And instead of having water, I've got hydrogen. But what about the oxygen? Well, notice that the other tack that's not bubbling, see if I can make it easier for you to see. It's actually starting to rust. And if I do this for a long enough period of time, you'll see that that tack will start to fall apart into the water because oxygen eats metal. So when H2O are all together in a water molecule, they behave like the way we know, ice, liquid water, steam. But when you separate H2 and O2, they become very different things. The hydrogen becomes a gas that wants to float to the top of the cup. And the oxygen, now that it's not stuck with the hydrogen, it starts to eat the metal tack. And that's what causes rust. In fact, here is an old horseshoe that I found down in the barn where I live. This is from a long time ago when they used to use winter horseshoes on the big draft horses so they could walk on the ice without slipping. But this is made out of mostly iron. But parts of this have turned red from rust, and that's actually oxygen. So when oxygen is with hydrogen, it's water. When oxygen is by itself, it can cause metal to rust. Now that might sound strange, but let me give you some pictures that might help you understand what we did to the water molecules in here. In fact, I have a model of a water molecule. It looks like Mickey Mouse, I know, but the white little spheres, these represent hydrogen atoms. And this is why we say H2. There's two H's, and the red sphere represents oxygen. There's one, so we don't have to put the number 1, we just put O, so H2 and O. And when I touch the battery to the cup of water, electricity started cutting Mickey Mouse's ears off. Ah! So when I did that, the O's were separated and they could eat the metal and cause the tack to rust. In fact, maybe you noticed the water is starting to change color. I think the rust is starting to make the water look a little weird. And the H2s, when they got together, they didn't have that heavy oxygen atom holding them down, so they floated out of the cup as little bubbles. So the bubbles were H2, and the rust is caused by this eating the metal in the tack. So this might sound strange, but when you study chemistry, if you learn more about these atoms and the matter and how they manipulate each other, you're going to find out that chemical reactions are very important to our life. Fire is a chemical reaction. So we turn the wood into energy and we get smoke as gases and we get heat and we get light and we get comfortable sitting by the fire. But chemical reactions are basically taking atoms and molecules apart and rearranging them in new ways. So even the simplest chemical reactions require a lot of disassembly and reassembly, kind of like Legos. So let me show you another way to understand this idea between atoms and molecules. Let me go to another app made by Mr. Theo Gray. I want to thank him for all the great apps and books that he's written on the elements. There's an app called Molecules that you can get, and in it you can look up what different molecules look like, and they're kind of cool. But I'm going to put up the one that we just talked about, water. And here you can see, oh look, just like my little Mickey Mouse. And if I push this button on the app, you can see the two H's and the O. So H2O, that is what we're talking about. And that is the molecule that makes water. And water molecules are made of different atoms, hydrogen atoms and oxygen atoms. And those atoms are what give water its special properties. So everything in the universe is made out of these different elements. And I hope while you're watching this video, you can start thinking about ones that you might be able to find around your house. After you're done watching this video, I hope that you go around your home and try to find examples of the different elements that are on the periodic table. Look at the matter that's in your house. Maybe you get help from some of your parents or some of the loved ones in your house, older brothers and sisters, cousins. Anyone who's with you can help you look in the hardware section of your house, maybe in the basement, maybe in the medicine cabinet, maybe in the kitchen. Please be careful. But if you search the products and the things you have in your home, you're probably going to be able to find examples of most of the elements that we're going to talk about. Hydrogen and oxygen, well, that's an easy one. I hope you have water in your house. That should be easy for you to find. But let's talk about some other ones. So let me go back to the Elements app here. And maybe I should talk a little bit about carbon. Now, wow, that's a fancy diamond. I couldn't afford that diamond, but I can afford the app that puts the picture on my TV, at least. And actually, I have some real diamonds here. These are not fancy enough to put into a ring. They're actually the kinds of diamonds that are not that pretty. Diamonds in the rough, kind of like Aladdin. These diamonds were destined to become tools. You can use diamonds to make tools very sharp. For example, if you look in the tool chest in your house, maybe you have a diamond saw blade or a diamond coated drill bit. If you make diamond into dust and you glue it onto a tool, diamonds can cut through anything. Diamonds can cut through glass, through steel, through ceramic. So the only way to cut a diamond is to use another diamond because this is such a hard material. Here, let me see if I can, well, I'm going to keep it in the case. I don't want to lose them. But look at that sparkling diamond on the Elements app and notice that it's C. C is carbon. And a diamond is made out of pretty much nothing but carbon. And that's pretty crazy because here is something else that's made out of almost nothing but carbon. This is graphite. Graphite is a rock that's mostly carbon, but it doesn't look anything like a diamond. It's solid. So is a diamond. They're both solids. But because of how the atoms are arranged in the crystals of a diamond and the crystals of graphite, they're very different. So they have different properties. For example, a diamond can cut through anything, but what about graphite? Graphite is so soft that I can actually cut it with my fingernail. And if I rub this hard enough, oh no, the graphite is coming off on my fingertip. I'm breaking a rock with my fingernail. That's not very hard at all. It's about as soft as you can imagine, soft enough that I can saw it with my fingers. Could I do that with a diamond? If I tried to cut through a diamond with my fingernail would rub off and the diamond would still be fine. But graphite is what you use whenever you write things down with a pencil. So if you don't know what graphite is, you've probably seen it a million times. It's the tip of your pencil, the thing you write with. Wait, don't we call that lead in a pencil? Yes, some people call it lead, but no, we don't put lead in pencils. Lead is actually dangerous. This is real lead. This is graphite. You see how they kind of look alike? But lead, we'll talk about lead in a little while. Lead is not stuff that we want kids to chew on, like your pencils. And lead is not something that we want to have lying around for kids to get in their bodies because this stuff is toxic. So we wouldn't make pencils out of lead, but we do make pencils out of graphite. So if you're looking for carbon, you don't have to have a fancy diamond ring. All you've got to do is have a piece of graphite like a pencil tip, but also see that wooden ceiling behind me and this wooden bookcase? Wood is also made out of carbon. Most living things are made out of carbon. I have a lot of carbon in my body. My hair is made out of mostly carbon. And when I exhale, can you see that? Maybe if I, well, you couldn't see the gases coming out of my mouth, but a lot of the gases coming out of my mouth contain carbon, but not solid carbon. Could you imagine? I would be burping up diamonds. No, not solid carbon, but a gas form of carbon called carbon dioxide. And that's another one of those molecules that I bet a lot of you kids have heard of before. CO2, carbon dioxide. If I go to the molecules app, you'll be able to see that here. Let's see if I can look it up. There is CO2. And if I put it into the 2D mode, you can see C in the center and O2 because there's two O's. Look, here's my little model of a CO2 molecule. One carbon atom and two oxygen atoms. So think of how strange that is. Carbon combined with oxygen can be a gas that's invisibly floating out of my mouth as I speak. But carbon by itself without the oxygen can be a solid like this graphite. So, graphite or diamond. So, carbon in a molecule or carbon by itself. As you study the periodic table, as you study matter, you'll discover that most of the things that we talk about in the world are molecules that are a mixture of different elements. Very few things that you see are just one element, but I happen to have a few examples of things that contain only one element. Graphite, diamond, those contain mostly just carbon. But here's an element that is very famous and perhaps even dangerous. That's gold. Now, why do they call it AU? Because the ancient Romans called it aurum, like aurora. That word aurum, or think of how the color of aurora or dawn, the golden color of a sunrise, is what gave the name to gold. And when I was growing up in middle school, I used to walk around with a nameplate that said Bobby like this, made out of gold. And if you have gold jewelry, well, this stuff is mostly just gold. If it's really good gold, it won't have other elements in it. So there's something that has just one type of atom. And maybe if you know how gold is turned into jewelry, you have to understand that gold, just like we can melt ice, we can actually melt gold. And if you look at the Elements app, you can actually see here, the little bricks tell you the temperatures at which gold will stay solid. And then this that looks like waves tells you the temperatures which gold will be a liquid, like molten gold. Did you see that Hobbit movie where they put that dragon in a bunch of molten, melted gold? Well, that's hot gold. And if you get the gold even hotter, Now, this might sound crazy, but if you get gold up to 5,172 degrees Fahrenheit, gold will boil. Now, I don't think any of you have a cook stove that can get up to 5,000 degrees Fahrenheit, but if you had a furnace or a forge, it would be possible to melt gold and then boil the gold, and then there would be gold floating in the atmosphere as a gas. It would probably be bad to breathe that in because when it froze, it would turn into gold inside of your lungs. But every element on the periodic table has a melting point, and for gold, it's only 1,947.5 degrees Fahrenheit. So if you get gold up to 2,000 degrees, it'll be a liquid. And then you can pour it into a mold and shape it into anything you like this cool guitar right here. But if you get your furnace hotter than 2,000 and go all the way up to 5,000 and above, then instead of getting liquid gold, you'll get gas gold. And it'll probably float away from your workshop, and then you'll lose all that gold. So you wouldn't want to do that, but that's one of the cool things about the elements. They all melt at different temperatures, and they can be used for different purposes. And gold is very fancy, maybe dangerous because people might kill you for it. Arr, like the pirates might come and snatch it from you. So be careful. But there's other elements that can be melted too. And let me show you one that I already mentioned earlier, lead. Lead, why do they call it PB? It's not peanut butter. In fact, it comes from the Latin word for lead. The Romans used to call this plumbum. And that's why there's people who work in a job called plumbing. No, we don't say the B. The B is silent, but plumbers and plumbing come from the fact that lead used to be used to make most of the pipes for water. In ancient Roman times, they used lead pipes, but now we know that lead is dangerous. It's too bad because lead is pretty cool. It's nice. It's easy to bend. It's very heavy, very strong, but you don't have to be very strong to move it around and bend it and make pipes. I mean, look at this piece of lead right here. It looks pretty solid. If this was iron or steel, would I be able to bend it that easily? No. So lead has a property that some metals have. It's malleable. It's easy to bend. And that makes it useful. Look, this pipe was bent out of solid lead. A flat sheet of lead hammered and twisted until it did that. Pretty cool, but also dangerous. There's a couple of reasons why lead can be dangerous, and here is one. I have some lead right here. These are musket balls. These are the old-fashioned kinds of bullets from the guns that were used during the time of the Revolutionary War. And in those days, soldiers and hunters, they used to reuse their lead bullets because if you fired this and missed a deer, missed that turkey, and the bullet goes into a tree, you could dig it out with your knife and melt it and reform it with a little mold, and you could reuse the same bullet over and over again. Why is that possible? How could you make a bullet at home? Well, if you look at the melting point for lead, it only takes 621 degrees to make lead melt. So even a campfire gets hotter than that. So if you had a pan and a campfire, you could melt lead. But unfortunately, we now know lead is toxic. Maybe you've heard of lead poisoning. Some cities in the world have lead pipes, and the lead pipes sometimes leak the lead into the water, and people who drink lead water can get brain damage. So we stopped using lead for pipes, but we also used to use it for paint. So you may have heard of lead paint, lead pipes. These are the toxic sources of lead in our environment, and hopefully we can get rid of all that lead that's still around in the world. Of course, I'm holding it in my hand now, but I know that if I touch lead, I need to wash my hands after I handle it because I don't want this lead to get into my body. Like what if I have a snack after this video and I eat something with my fingers, I can get lead poisoning too. So I always store this in a plastic bag, and I always wash my hands after I touch lead, and you should do the same. But you could have lead around your house. Maybe one place to look for it is the flashing around the chimney in your house. A lot of old chimneys have lead used as a seal to keep the water from leaking in. And if you look outside your house, you might see, if you have an old house, even a new house, if you have a brick chimney, it probably has some lead flashing If you can't find one of these musket balls around your house, you probably have lead somewhere. But you're not eating off your chimney, so it's safe up there. It's not safe to have inside your house in your water pipes. So we stopped doing that. Well, I am talking about dangerous elements. Since I might as well mention one of the coolest. Mercury. This is beautiful stuff. Hg, why'd they call it that? That's also from Latin, hydrogyrum, which means water silver. And that is a good way to describe mercury. I have some inside of a glass vial here, and you can see that it acts like water. If I shake it, it turns into lots of little drops, and then they roll together. And this stuff is really cool, and generations ago, kids used to play with this stuff. But we've also learned that mercury can be toxic, so that's why I keep it sealed inside of this glass tube. I wouldn't want to let this out. I wouldn't even want to touch this with my bare hands. A long time ago, people used to use mercury to make fancy hats. And you coated the fur hat with mercury to make it shine and to keep bugs from eating the fur. And if you were a hatter and you spent enough time working with mercury, eventually the mercury would get into your skin and into your blood, and it would mess with your brain, and mercury would cause hatters to become mad. Ever heard of the Mad Hatter in Alice in Wonderland? That character is inspired by the fact that many hatters often had brain damage from working with this really cool but dangerous element. So, lead, mercury, they're cool, but they're dangerous, and we try to limit how we use them. However, mercury, check this out, think about this. It's metal, but it's already melted. Can you freeze mercury? Well, sure. But to get mercury to be frozen, I've got to wait until a really cold night in the winter. It doesn't freeze until it's about 37.9 degrees Fahrenheit below zero. So for mercury to turn into a solid piece of matter, it needs to be like 40 below zero, super cold. If I took this to Penguin Land, Antarctica, then mercury there would be a solid metal. But in most of the world, in most weather, mercury is going to be a liquid. And the most dangerous form of mercury would be if you boiled it, and that only takes 674 degrees. So that's easy to do because 674 degrees is not as hot as a campfire. And if you threw mercury into a fire, it would boil, and anybody standing nearby would breathe in mercury vapor, and that can poison people and even cause death. But that's why we got to be careful, kids. Because a lot of the things that we use in our world, see this thermostat? A lot of people have these on their walls to control the temperature of the heater. Turn down the heat, our energy bills are too high, but I'm freezing, turn it back up. Well, when you're messing with the thermostat, there's actually a piece of mercury inside that helps turn the switch on and off depending on where the dial is set. So actually, that's a way we use mercury. You might have this in your house. Don't be afraid of it. It's not going to hurt you as long as it stays inside of that glass tube. But imagine how dangerous it would be if somebody tried to throw this into a fire. You would be causing toxic pollution, and anybody near that fire who breathes in the smoke could be poisoned by the mercury vapor, the mercury that boils once it gets into that hot fire. So things that have mercury, any electronics, even some of our smartphones and the iPads that I'm using to do this video have mercury inside. So that's why we have to recycle these objects, because we don't want to put this kind of stuff as pollution into the environment. So elements, they're cool, they have their uses, but they can be dangerous. And here, let me talk about one that's not as dangerous, but one that you probably can find easily in different ways. Sulfur. S. Well, here's a chunk of sulfur right here. A bright yellow rock. In ancient times, it was called brimstone. And sulfur, is the source of most stinky things in this world. When you don't brush your teeth, the bacteria in your mouth make hydrogen sulfide. That's a molecule, hydrogen and sulfur mixed together. And hydrogen sulfide is what gives you bad breath. And sometimes, especially if you eat a lot of beans for supper, you can make hydrogen sulfide in your intestines. And then that gas, a combination of hydrogen, H, and S, sulfur, will make everybody in your house run out of the room saying, "What did you do?" Yes, because when you pass gas and you fart, and when you have stinky breath, it's sulfur that you're smelling. Hydrogen sulfide is the smell of a fart. Hydrogen sulfide is the smell of bad breath. And when a rotten egg goes rotten, it's hydrogen sulfide that you're smelling. And if you eat garlic, garlic is rich in sulfur, and that's why garlic probably smells so strongly. And onions are rich in sulfur. When you cut into an onion, the reason why it makes you cry is because of the sulfur. It hurts your eyes, it stings your eyes, and it makes you tear up. So if you use this Elements app, you'll see all kinds of funny pictures like that you can interact with. Sulfur comes in many different forms, and if you plant blueberries, you might even put some on the garden to make the ground more acidic to help you get more blueberries. So there's a lot of places where you're going to find sulfur. Even skunks use it. When a skunk sprays you, and I hope this doesn't happen, but skunk smell is the smell of sulfur. So if you could smell through this video, you might recognize this stuff. But that's just one of the many elements on the periodic table that you can explore. And in the little bit of time that we have left, I'm going to tell you about two other ones that are very strange. One of them is called sodium. It's a metal. This metal is dangerous. It's explosive. If it touches water, it blows up. And actually, the gentleman who made this app, Theo Gray, made another app called The Elements in Action. And you can see what happens when a chunk of pure sodium touches water. I don't want to touch that with my bare hands. It's explosive when it touches water. Isn't that strange? Well, why would anybody want to have any of that sodium around? It seems too dangerous if it explodes when it touches water. In this picture, they're storing it in mineral oil. Oil and water don't mix, so the oil keeps this from getting wet, and that keeps it from exploding. But you might be surprised where you could find sodium. I'll tell you where in a moment, but let me show you one more element. Another dangerous element that's usually a gas. Chlorine. Cl is for chlorine. And that glass container has a gas that's too dangerous for us to breathe in. If I breathed it in, it would kill me. That sounds horrible. Now, you've heard of Clorox. There are things like bleach that have chlorine in them, and Clorox is dangerous stuff. In fact, this stuff can kill you if you drink it, but it kills germs, so we can use it safely. We can put a little bit of chlorine into a pool and kill all the germs, but that's too little to hurt us. But too much chlorine will kill anybody and anything. So you might be surprised that there's a molecule that all of you know very well that is 50% sodium, the explosive metal that blows up when it touches water, and 50% chlorine. Now, here is a model of that molecule. You saw when I showed you CO2. Well, here is NaCl. It's a crystal. The blue ones are the sodium. The green ones are the chlorine. And an NaCl, which is called sodium chloride. See? Sodium, chlorine, sodium chloride. This crystal looks like this on the molecular level. The atoms are arranged in tight formation, and there's equal numbers of greens and blues. You see that? Well, if I separated them, this is not real atoms. This is just a model, kids. But if I have them together, I've got sodium chloride. If I separate them, I've got pure sodium. If I got pure chlorine, ouch, I hit my head. But anyway, but if I put them together, do you know what sodium and chlorine put together are? Salt. This is salt. Isn't that strange? Elements can be very dangerous when separated, and when you put them together, they can be pretty harmless. I mean, salt makes your French fries and your popcorn tasty. Nobody has to worry about exploding from eating salty food, and you're not going to get poison gas from eating a salty potato chip. But I'm not going to teach you how to separate these two, but a chemist knows how to make sodium and chlorine separate, but they also know how to handle them safely without getting hurt. That's not something that you can do at home, but I bet if you go around your house, you'll be able to find elements of all kinds. You probably don't have to do too much work to find something made out of carbon, wood, paper, made out of carbon. Maybe you can find something made out of aluminum around your house. That's number 13 on the periodic table. Now, here's a funny thing about aluminum. A lot of people call it tin. This is not tin, but I actually have tin. Tin, aluminum. Do you see why people get them mixed up sometimes? Tin and aluminum look a lot alike, but aluminum is that one, and tin, which a long time ago kids used to make tin soldiers out of. There is something that if you lived a long time ago you might have done for fun. Melting tin, not so hard because it melts at only 449 degrees Fahrenheit, so you can melt it really easily. And kids used to make soldiers and other fun little sculptures out of melting tin. So tin, not aluminum, but I bet you can try to find some of these things in your house. See if you can ask your folks about finding some lead. Maybe you'll find some gold in jewelry. Maybe you'll find some sulfur. Go to the kitchen, hint, hint. And maybe you'll find some carbon graphite in your school supplies. That's actually pencil lead all ground up. And there's so many other elements that I couldn't talk about because, after all, look at this. There's hundreds of them, 118. And in fact, like I said at the beginning, 1 through 92 are natural elements. Not going to be able to talk about all of them in this short video, but I hope by watching this, you get more curious about the matter in your universe. And then every time you find something strange, ask yourself, I wonder what's in here. What is this made out of? Which atoms combined to make which molecules to make this possible? So maybe the last thing I'll show you is something that's pretty cool. This looks like gold, but it's not. Some people have called it fool's gold. This, I showed you real gold earlier, but you can see how they look a lot alike. This is actually iron pyrite. It is a combination of two different atoms from the periodic table. One of them you just heard me say, iron. But iron is only part of what's in here. This also contains sulfur. So here you have a rock, iron sulfide. Iron and sulfur mixed together, and you get this really cool crystal that has some of the properties of iron. It's hard, it's shiny, and some of the properties of sulfur. It's yellow in color. And pyrite, iron sulfide, fool's gold. The reason why we call it pyrite is because if you had this, you could become a pyromaniac. You could start a fire with this. Pyrite, if you hit two pieces together, makes a lot of sparks. And for a long time, people around here, Native American cultures like the Abenaki folks, and people all around the world have used rocks like pyrite to start fires. Don't get any bright ideas. Please don't start a fire unless you have adults and parents watching you. But maybe you can find fool's gold or something else with sulfur. And I hope that after you finish this video, you go out there and look for as many of the elements as you can find. Look for the rocks in your backyard. Look for the kitchen supplies and the household cleaning products that you have. You might be surprised how many elements you can find. So your assignment, I would like to say, is to make a list of all of the objects that you find that have different elements and see how many total you can find in your house. How many of the 92 natural elements can you find? I don't expect you to find uranium lying around, but I bet you can find at least a dozen of these. So that's my challenge to you. And I'm going to end this now, but thank you for watching this introduction to matter and the elements on the periodic table. You probably noticed that I'm wearing them on my shirt just in case I forget them. And as you get more advanced in your knowledge of chemistry, you'll start to understand why we organize this chart. This chart is this way for a reason. But first, start by getting familiar with the elements. So thank you all for watching. Again, my name is Bobby Farlice-Rubio, and I work at the Fairbanks Museum and Planetarium in St. Johnsbury, Vermont. And I hope you have a positive encounter with all the elements that make our universe.